Today I'm going to be trying the hardest math questions given to 18-year-olds from 7 different countries, and at the end I'll tell you which question is the hardest. The first question is from the American SATs, which they give to 18-year-olds. Fun fact, we do have something called SATs in the UK, which is spelt SAT, although that's a test that we give to 11-year-olds, but obviously it's a lot easier than the one that they give to 18-year-olds. So the question is 24x squared plus 25x minus 47 all over ax minus 2 equals minus 8x minus 3 minus 53 over ax minus 2 is true for all a where x is not equal to 2 over a. So a is a constant, find a, okay? Obviously this is just saying that these denominators can't be 0, so we can basically ignore that. First thing, I see a denominator here and a denominator here, which is the same, so I'm going to multiply. Now we've got this factorized term, so I'm going to expand the brackets. And suddenly we see that the minus 47s actually cancel on both sides, so that's quite convenient, because it also means that we've got an x that we can actually factor out of both sides as well. Now, a lot of people at this point would just say, oh, divide by x, you got both sides, you can take it off. But that's not rigorous, because if x is equal to 0, then you can't divide by 0, so that's not true, okay? Instead, what I'm going to say is x is always equal to x, so these two terms are always going to be the same. So for the whole thing to be equal, these two have to be the same. So I'm just going to ignore the x, not divide by x. That's important. Now, just by looking at it, you can see that this is 8 lots of something gives us the x term. 3 lots of something gives us this term, and you can see that, well, 3 lots of 3, okay? But obviously, because there's a minus in front of it, a is going to be minus 3. So that is my final answer. Let me see if I got it right. Yeah! Screw that, America. India.
It's not a joke.
This question is from the CBSE, and it says, show that the right circular cone of maximum volume that can be inscribed in a sphere of radius r has altitude 4r over 3. So a right circular cone seems to me to be just a cone that's not like lopsided, I guess. So it's like, it's right up, it's right angles, which makes sense, okay? And it's inscribed in a circle of radius, a sphere of radius r, and it's supposed to have, oh, this is interesting. Okay, so I think a right circular cone is just a cone that's like straight up. So this here is supposed to be 4r over 3, and we know from the question that the radius of the sphere, which will go from the center, is exactly equal to r. Okay, so my first attempt is just looking at the trigonometry of the situation and seeing that this long side of the cone here seems to form a nice triangle with r, the other r, and because they're both going to be radius r, because they're both going to be connected to the edges of the cone and from the center. So we're imagining from the center here. Let's see what this makes. So how do we even find the angle there? Never mind. Welcome to India, bro. That's what we're talking about. Welcome, doing real math now. Here's what I'm gonna do, okay? So the radius of the sphere, I'm gonna call it big R. The radius of the base of the cone, I'm gonna call it little r. And this way, what we can do is we can form a triangle. This is the cross section of the cone, and we also can form the circle. Now, the circle's gonna have some center point. It's, in my imagination, it's gonna be right in the middle, and I think we can assume this fair enough, because even if the cone is not in the middle, you can still orient it so that it's pointing directly up, and it's a right angled cone anyway. This length here is going to be r because it connects the middle to the edge of the sphere. This length here has got to be r, and this length here is some x value we don't know. This length here is some r value, and so we've got little r here is the base of the cone, right? So we need to find h. H equals r plus x, okay? So as long as we can find x, which should be 1/3, then we can find the whole thing, okay? So what we've got here is a right angle triangle. We've got some angle here, theta, so we can say that x equals r, oh, actually, we can do one better than that. We can just go r equals r cos theta, whatever theta is. We'll leave it as an imaginary variable we don't know yet. Okay, so I've got a quadratic equation here. Look, x squared plus 2x plus 1, and then we can factor out the signs, and then we've got plus 1 squared. Okay, we're looking, that looks, wait, hang on, this is wrong. This makes no sense. If that's equal to 0, then sine theta is equal to -1, which would say that theta is 270 degrees. How is theta 270 degrees? I've made a mistake, okay? I'm not gonna throw in the towel yet, okay? I'll keep trying. Okay, so I've reset my brain and I've thought again, okay, what do we need to do, okay? Rather than confusing myself with the geometry of the situation, the signs, the trigonometry and all of this stuff, what we really need to do is we need to take R in terms of the other two variables, we'll call them X and big R, okay? We need to find the volume of the cone, okay, as an equation, differentiate that equation, find where the differential is equal to 0, which will give us our maximum point, and then just find the maximum point, okay? So I'm up to this point now. I've differentiated it. Now, let's hope this works. So I just simplify. Okay, so it seems like we've got this equation here. Now, let's just see if we can treat it as a quadratic. So we've got 3x squared plus 2xr minus r squared equals 0. Divide by 3. Actually, let's just do the quadratic equation. X equals minus b plus or minus the square root of b squared 4ac all over. Come on, simplify please. Simplify please. So minus the square root of, that's supposed to be outside, 4r squared minus 12, but it's going to be plus, so it's going to be plus 12r squared. All right, looks good so far. Minus 2r plus or minus the square root of 16r squared. That's a square number. I think I'm gonna. X equals minus, so we've got plus or minus, so minus 2r plus or minus, but because it's a geometry problem, it's not going to be minus 2r minus another thing, because that would make a negative radius, which doesn't work. We don't have negatives, okay, in geometry. So we've got positive 4r all over 6. What? Oh, wait. I got confused for a second. Never mind. And then that I thought it was adding, so I was like 6 over 6 is 1r. No. We're taking it away, so it's 2r over 6, which is r over 3. X equals r over 3, so r plus x, r plus r over 3 is 4 over 3r. Boom! Have that, India! Have that! Next question is from the best country on the list, the UK. And this one is from the A-level exams, commonly quoted as one of the hardest questions. The curve C is defined by x equals 8 sine squared t, y equals 2 sine 2t plus 3 sine t from t is 0 to pi over 2. R is bounded by C, the x-axis, and r equals 4. Find R, okay? Now, I think usually there'd be a nice little diagram on this question, but stupid, silly me forgot to copy the diagram onto my phone. So basically, I'm just gonna have to sort of wing it by just imagining the curve. So let's start with a curve. We've got the x-axis. Now, I'm gonna draw a sketch here. I don't have any clue if this is gonna be right, but we've got x equals 4, which we'll put here. We've got the x-axis, which is obviously the x-axis, and then we've got 8 sine squared t. I am just going to hope that it's like some curve like that. I really don't know, okay? I've got no clue how I would even decode that. So let's just assume the region R is in here. Now, I actually forgot how to do parametric integration, which is kind of a little bit awkward because I'm not allowed to use the internet. So I think you do dx by dt, so you can find dx by dt. So this is f of x we use here, okay? So how do we do that? I think that's it from memory. I really don't know. Okay, I'm not gonna lie, I did take a sneak peek at the parametric differentiation, and it's actually y instead of f of x. Okay, I was confusing myself for a very long time just staring at that. So we've got the 2 sine 2t plus 3 sine t. Then we have to do dx by dt. Now I've decoded the sine squared to make this, okay, which should be sine squared t. So dx by dt, well, x is actually 8 times this, which is 8 minus 4 cos 2t, okay? So there's our x. Then we can differentiate this with respect to t. We've got minus 8, oh no, it's gonna become a plus, minus cosmix plus sine 8 sine 2t. Yeah, that's right. It doesn't look right, but it's right. Just looks too satisfying. Anyway, there's our 8 sine 2t. Oh no, I have to integrate that. Okay. 8 sine 2t. So that's our dx by dt, and then we've got dt. And then also we've got to have the limits as well. What's t here and what's t here? Okay, so we want to know when x equals 4, let's say. X equals 4. So that's 8 sine squared t. So sine squared t is a half. So sine t, 1 over root 2, or root 2 over 2, which is 45 degrees, which is pi over 4. T equals pi over 4, which is halfway along here. Okay, interesting. Is there multiple values though? Yeah, there is. But for the pi over 4, you've got that. So it comes up and then it comes down again. Yeah, so there's 2 values here. Okay, there's pi over 4 and then there's 3 pi over 4. Wait, that's not right. Yeah, because that goes over. So we ignore that. Okay. And then we've got when it's 0, when y and x equals 0. So this equals 0. So 0, sine t is 0, so we've got 0. So basically we've got t is 0 and t is a pi over 4. So I'm just gonna put in those values, okay? And that should be our limits. So now I've got to expand that out and integrate it. Oh, it's gonna take some time. So I have been going to work on this integral, and as you can see, I've been using a method called integration by recursion, which I don't even think you're supposed to do in A level. So that's already not a good sign, but I ended up with an answer, okay, for the integral of this, which is here, 24 sine t sine 2t. So we'll see if it works. So I'll put integral of cos. So let's do the integration now. So integrate 16, we get 16t. Integrate this minus cos, the minus cos turns to minus sine. So we get minus 2 sine, you divide that, yeah, minus 2 sine 4t. So that would make minus 8 cos 4t, yeah. This is supposed to be a plus 24. And then we've got to integrate this, which is apparently, according to my integration by sheer brute force attack, is 2/3 sine 2t cos t minus 2/3 cos 2t sine t. And then you stick the limits on the end, 0 to pi over 4, and that should be our answer. Oh wait, I have to work it out now. Okay, so I've just realized that each of these terms contain, well, this is t, this contains a sine of something t, so when it's 0, it's gonna be 0. This contains sine of something t, this contains sine of t, so all of these are gonna be 0 when it's 0, so we don't even need to include the term where it's all 0, so we can just calculate it by substituting in pi over 4 for t, and we get 16 pi over 4, which is 4 pi minus 2 sine pi is 0. Sine pi over 2, that gets to the top, so it's 1, so we can just ignore that. Cosine pi over 4 is the same as sine pi over 4, which is root 2 over 2, so minus, so 16 plus, so this plus 16 root 2 over 2, which is 8 root 2. So we've done that one now. Minus 16 cos pi over 2. Cos goes down, so cos pi over 2 is just 0. So the whole term cancels. So it is, according to my estimations, the answer is 4 pi plus 8 root 2. I would be astonished if I got that right. Astonished. I got exactly 2 times the answer. So I've dropped a 2 somewhere. I've got, yeah, I've that's funny. I have exactly 2 times the answer. Maybe there was something on the graph that I didn't see, but the answer is actually 2 pi plus 4 root 2. I got 4 pi plus 8 root 2. So this was the first one that I actually got wrong, by the way. And to be honest, I mean, just look at the mess that I've made on here, okay? I hate integrals with parametric equations, with with trigonometry. Really, like this is like the bane of my life, this question. So I'm just happy that I got something close or similar to the answer. Now the next question is from Deutschland, and it's a paper called the Arbiter or something like that. This one is very interesting, and it's not something that I've seen before, okay? A sphere with radius 3 and center 1, 1, 1, and another sphere with a radius 4 and a center 4, minus 2, 2, intersect. Find the common circle of intersection with center M and radius R and the equation of the plane. So what it's saying is we have two spheres, one of which centered at 1, 1, 1. That's tiny. Anyway, who cares? You don't need to see that. And one of which centered at 4, 4, minus 2, 2. And they intersect at a common circle. Try draw a common circle with a center M and a radius R. Okay, and we need to find the common intersection point. Now this is very interesting. What we can do is we can find this here and this here to be the radius of each of these. So this is going to be 4. This is going to be 3. Okay, we're going to have a radius R here of the little circle, the intersection circle. That's going to connect those two. So if we find that this intersection here, this M is they've used a convenient letter because it's actually going to be the midpoint of these two.
One eternity later.
M equal to this and R equal to root 17 over 2. Is this correct? Check my answers. Check my answers. I got it wrong. Wait, it doesn't have to be the midpoint, or does it? Yeah, it should be. Okay, so I've checked the answers and I've made a big fat oopsie. This isn't necessarily the midpoint, okay? And I just assumed that it was. But yeah, theoretically, this doesn't have to be the midpoint between these two. So I made a big oopsie with this one. This line is terrible. It's just wrong. It's just plain flat out wrong. And we've got to do the whole thing again. Okay, so I've missed the point that it says prove that it intersects. To do that, all you have to do is just say, well, the distance between this and this is less than 7, so obviously it's going to intersect. But what we can actually do is if we calculate the distance between those two, so the distance between A and B, we've got 3 squared. We've got the square root of 3 squared plus 3 squared plus 1 squared, which is the square root of 19. Okay, that's the distance between that and that. So then all we have to do is say, okay, we've got a triangle with root 19 here, 3 here, 4 here, and we can do a bit of trigonometry to calculate, we want to calculate the radius in here, don't we? So A squared equals B squared plus C squared minus 2BC cosine. I think this is the cosine rule. I might have gotten the signs mixed around. I don't know. Is it like this? No. I think it's this way. Yeah, with the minus and the plus here. Okay. So we've got A squared. We'll use, so we want to find, let's say, this angle here. Okay. I'm just doing it so that we can find the middle one. So this angle is, so we've got A is 4 squared equals B, we'll use 3 squared plus C squared is 19 minus 2 root 19 times 3 cosine. Wait, but I don't have a calculator, so that's going to be not very good. Okay, let's not do that. Okay, so I think I've worked something out here. So I do use the cosine rule, but I don't actually need a calculator because if I find cosine of A, I don't need to find the inverse cosine. I can just leave it like this. I can simplify that to minus 13 over root 19, which is minus 13 root 19 over 19. And then, wait, how can an x be a negative? That's not right. Maybe it is. Oh, that's supposed to be negative. Okay, so I've done the cosine rule anyway because I've actually realized you don't need a calculator. You can just leave it as square roots and then you get a positive answer for the x here, which I've labeled this part here as x. And then you can take okay, so we found this part here as x. Now we know this here is 13 root 19 over 19. Then this here is 4. And so we can just do Pythagoras' theorem to find, because this is a right angle triangle, to find the radius r. So 13 squared over 19 plus r squared equals 4 squared. So 13 squared is 169. 69. 19 plus r squared equals 16. Okay, 16 times 19, what's that? What's 16 times 19? Mental maths, 16 times 19, 54. 9 is 14, 0, 6, 1, 4, 0, 1, 304. Okay, so we've got 304 over 19, and then we've got to subtract this. So we've got r equals 3 over 4 minus 169. What is that? 5, and then you've got 299. No, yeah, 299. 304, 169. Subtract the 2. So you've got 4 minus 9, can't do that. So 2, 1, 9, 1, 4, 5, 6, 3, 1, 135. Okay, 135 over 19. Root that, we've got root 135 over 19 should be our radius. And if it is, I'm going to consider this question done because I'm not going to go through all of that to find just the radius. Okay, I think this question was pretty hard, to be fair. The Germans have got it pretty tough. R is, yeah, good, school like Deutschland, Deutschland. So I'm going to consider this question solved because I really can't be bothered to go through this whole process again to find the m and then to find the equation of the plane. The equation of the plane is, how would you find that? Oh yeah, it would just be normal to this line. Okay, so the equation of the plane is kind of self-explanatory. It's just a normal to this line, whatever. No big issues there. Next one is from Canada, the land of the maple leaf. It basically just says a point A and minus 2A with A greater than 0 lies on a unit circle. A is equal to m over root n, and m and n are integers. Now, I just asked ChatGPT to give me like the most hardest questions it could find for each country, and this is what it came up with. So Canada, don't get offended if this seems like a very easy question, but it does to me, okay, because we've just got a unit circle, okay, A minus 2A, so it's going to be like this. A minus 2A is on the unit circle, and we just need to find m over root n such that this is a unit. So it's a unit circle, so the radius is 1. So A squared plus 2A squared, just using Pythagoras' theorem, equals 1 squared. A squared plus 4A squared equals 1. So 5A squared equals 1. So A equals 1 over root 5. That's literally it. Like, m is 1, n is 5. Is that correct? I hope that Canada does have harder problems than this, and this is just a ChatGPT moment. But honestly, 1 and 5, yeah, that's the right answer. So Canada, your question was way too easy, okay? The next one is Poland, and it's from the Matura. This one's another easy, very easy looking one. So I don't know what's going on in Canada and Poland, why you've not got difficult maths questions, but we have basically a regular pyramid, which implies that these are all gonna be 6, and then there's a height, and then it gives us a volume as well. Now, the volume of a pyramid is equal to, I think, a third. When it's triangles, is it a quarter or a third? I don't know if it even matters, really. I think it's a quarter? Is it a third? Let's do a third, see what happens. Third, no, well, there's no pi. So with a pyramid, I know with a square-based pyramid, the formula is a third times the base area times the vertical height. In this case, we know the vertical height, well, if we get the cross section, there's going to be 6 along the bottom, so there's going to be 3 there. It's going to be 6 here. So 3 squared plus 6 squared equal, 3 squared plus vertical height squared equals 6 squared. Height squared therefore equals 36 minus 9, which is 27. So height is going to be root 27, which already looks kind of interesting. Height is root 27, so we've got root 27. So we've got root 27 times, is it root 27? It's got to be, yeah. Root 27 times 6 on the bottom, and then we've got, oh yeah, it is times a third, because we've got to get the area of the whole thing, which is going to be 6 times root 27 over 2, which is going to be 3 times root 27. So that's the area of the base. So we do the area of the base, 3 times root 27, times by, is it going to be a third? Yeah, it's got to be a third. And then we end up with, that cancels with that, which gives us 27, which is not correct. So something's gone funny with this. Okay, so I don't quite remember what the formula for the volume of a triangular-based pyramid is. So I'm just going to assume that I probably did okay, and just guess that, I guess you have to, well, we have to find the surface area anyway, right? Oh, yeah, no, it's a regular based pyramid, so the surface area is just gonna be the height. Okay, so the height has got to be 27 root over the root 3. I get what's going on. Okay. So the height has got to be 3, because root 27, no. Root 27 over root 3 is root 9. Yeah, so it's got to be 3. So that's got to be 3. So the height's 3, that's 3. So it's just, so the volume has got to be base, which is this, 3 root 27, times the height, which is 3, divide by 3. No, that's completely the wrong way around. Oh, wait, no, it's fine. Wait, yeah, times by 1 over 3, which cancels one of the 3's, which gives us 3 root 27. But root 27 is equal to root 9 root 3, which is equal to 9 root 3. Okay, so it's not divide by, so we've got to times this answer by 3 somehow. Get that? So instead of doing 3 here, I'm going to put 9 here. So I'm literally just doing trial and error, okay? This is literally the method that I'm going with. Try 9, see what we get. There's probably a better way to do it. 3 times, so we've got base times height times a third gives us volume. That cancels with that. We've got 9 root 27, which is equal to 9 times 3 root 3, which is equal to 27 root 3. So there's our volume. Okay, so we found the height is equal to 9. And then, now that we know that, we know this is equal to 9. So we can do a bit of Pythagoras here. So that's going to be 6 is the devil's number. Okay, this has got to be 3. Okay, so now let's deal with the base of the triangle, okay? This might be a little bit of a complicated way. There might be an easier way to do it, but I'm just going to do it my way. So this is 6, the devil's number. And then we've got 120 here. So we can actually split this in half anyway. So we've got 3 here. So that's a right angle triangle with an angle 60 degrees here. So that's going to be, we want to find this, which we'll give it a letter R. R sine 60 degrees equals 3. So sine 60 is root 3 over 2 equals 3. That's times by R. So R is equal to times, R is equal to 6 over root 3. Yeah, that's right. So 6 over root 3 here. 6 over root 3. So then we just need to do right angle triangle 9, 6 over root 3. 9 squared plus 6 over root 3 squared is 6 squared over 3 equals whatever this length here is, because we want to find this length, we'll call it L, which is equal to 36 over 3 is 12. 9 squared is 81, so it's 81 plus 12. That's way too big. Oh wait, L squared. Pythagoras' theorem. Okay, 81 plus 12 is 83, 93, so it's root 93. So L is root 93. L is root 93, which gives us this. And then we need to find the surface area. So we've got a triangle here, root 93, root 93. This is going to be half the base along here, which is 3. So we've got to find the area here, which is going to be, let's just do Pythagoras' theorem again. So we've got root 93 squared equals 3 squared plus whatever this height is here squared. 93 minus 9 equals height squared. 93 minus 9 is 84 equals h squared. So h is root 84. So we've got root 84 here, and we've got to do this times this. Should give us 3 root 84, which is the surface area of the triangle. So we've got 3 of those triangles. So times that by 3, plus we've got the triangle on the bottom, which is a equilateral triangle with side length of 6. So to find the area of that, that's going to be 6 at the bottom. 3 makes 3, 6. So 3 squared plus something squared equals 6 squared. Something squared equals 36 minus 9, which equals 27. So B equals root 27, which is 3 root 3. Okay. 3 root 3 root 3 is this here. 3 root 3 times that by 3. 3 times 3 root 3. And then we've got 9 root 84 plus 9 root 3. 84, can that divide by anything? It can divide by 4. So we've got 18 root 21, and that can't divide anything, plus 9 root 3. Okay, that's my final answer. Lots of working out. It was all quite easy, to be honest with you, but if I got it wrong, then I'm just going to be chewing on my own words. I did kind of just speed run it. 9 root 3 times 1 plus 2 root 7. Yeah! Take that, Poland! Okay, so this next question is from BRATHIL, which is the NM exam. This question is very unique, okay? I have to say that because I've tried to draw a diagram. Apparently this is a car door. It looks a little bit like a car door, I guess. But you've got y equals log x. That's going to obviously intersect at some value wherever the base is. I assume the base is 10 for just log. We've got to express h in terms of n. Okay, so really we've got to just find this in terms of this, and then once we've got that, we just multiply by 2. So we've got to do this in terms of this, and once we've got that, we just multiply by 2. So this is log, so I'll assume it's log 10, I guess. So this will cross at 10. And then we have, if we just transpose the entire thing, so let's just move the graph so that it comes at 0. So we've got here, 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 like that. So it just goes through 0. And then that's going to be, if we're assuming log is of base 10, then we got to do x, and then we got to add 10. So x add 10. So that would make, well, that would literally just be, yeah, that would be. Wait, no, it crosses at 1, doesn't it? Wait, hang on a second. X is 0. Log 10 of 0 is just 1. So yeah, it crosses at 1 always. So that's always 1. So it's literally just log x minus 1, okay? So we've got 1 here. We've got to find h2. How will we even do that? Okay, so this point here is going to be x comma function of x, or x comma y. So this point here, let's get rid of this here. Okay, let's just focus on the graph. So the graph is like that sort of, with a 1 here. This is 1 plus n. So x equals 1 plus n. Y is just going to be h over 2. So y we know is log of x. So y equals log of 1 plus n, which is that right? Yeah, that's got to be right. H over 2. So h equals 2 log 1 plus n. Is that it? Is that really it? Let me see here. No, it's way more complicated. Honestly, Brazil, I don't understand your question. Why are you wording it in this way? It's just so confusing. Just give me numbers and graphs, okay? You don't need to, the car door and the height and the base. What base? What base? What base? There's no base here. I actually think that the answer that ChatGPT gives here is wrong. Okay, I think that my answer is correct. There's gonna be, okay, Brazil, I'm sorry, but ChatGPT done you dirty here, okay? I don't know what the hell it's come up with, what kind of question. Apparently it was on, let me get the code for you so you can look it up and see what the NM 2015 Caderno Azul, question 154. Quite a lot of questions. Yeah, I don't know. Okay, so this one is from Australia, HSC, NSW, HSC, so New South Wales, is it? HSC Mathematics Extension 2, question 14, complex numbers, which is interesting because in my school, we didn't do complex numbers unless you did further maths, but in this one, it seems like they're doing complex numbers. Z is a complex number with an argument condition. So it just basically says, show that it's an arg of Z is equal to some interval, I guess. Let's do A and B. So let's do Z equals X plus IY. So we're going to have arg of Z is, if arg of Z is, let's say, alpha, then we're going to have Z, then we're going to have X, y over A. Alpha is arctan y over A, y over X, because that's how you find the argument. And then if you have another one, arg of Z beta for the B. So I've used alpha and beta here. So let's change this. Then we've got beta equals tan. So we've got the same equation basically. So let's use y1, y2, and x1, y2, x2, y1. All of those, okay. And then we've got to show that this is an arc. So for all values, we've got to basically prove that this gives us an arc. How are we going to do that? Okay, so tan B equals y over x, which is equal to sine B over cos B, Bill Cosby. And then tan A, so y, we'll call it y2, x2. So we've got y1 over x1 equals sine A over cos B, cos A, cos alpha, times it by x cos alpha. Cos alpha y1 equals x sine alpha, x1 sine alpha. I really don't know, to be honest. Square both sides. That doesn't help us. How do we prove that this is an arc? Okay, so let's say arc Z is A. So I'm going to cut Australia out of this one because I don't understand this question at all, and I don't even think it's a question. So I'm going to cut Australia completely out of this one. Sorry, Australia. Sorry, Australia. Okay, so out of all of those, the hardest I've got to say is probably going to be the UK. Now, I know I'm a little bit biased because, well, I'm from the UK, but we just know in the UK how to put all of these questions together and get some monstrous questions with parametrics, integration, trigonometric functions. That was just a horrible question, okay? In terms of fun though, like actual problem solving, I would say India's was the best, okay? India's was definitely a brilliant problem-solving question. It's just a shame that we don't have that in the UK, and instead we just have horrible, painful integration that you have to fill up an entire board to solve. Anyway, those were my questions that I picked. If you think that there was a harder question that I could have tried for any one of these, it's got to be done by all the 18-year-olds or pretty much all the 18-year-olds, then let me know in the comments below. Like, comment, subscribe, and piss off.